Hey guys, I'm just continuing straight on from the previous video. So we just need to find the compression in the concrete. Now you should be used to the formula that the compression in the concrete is given by alpha 2 FC dash by gamma dn by B. This is essentially saying it's the stress times the area will give us the compression. Now we've found in previous videos that alpha 2 and gamma, alpha 2 was 0.85 and gamma was 0.7. So these values don't ever change because they're only dependent on the strength of the concrete. So they're not going to change for any point we're looking at. So working this out, we would have 0.85 by 50 MPa by 0.7 for gamma by 92.5, which is what we found in the previous video for the distance to the neutral axis, times by B 100, which was the width of the concrete. So if you were to work that out, you would find you would get a compression in the concrete of 275.2. The second last thing we need to do is work out the axial load in our section. The axial load is going to be the sum of the compression minus the tension in the steel layer 2 minus the tension in steel layer 3. So the compression, so this would be steel layer 1 was 113.7, so 113.7. Plus the compression in the concrete was 275.2, minus steel tension layer 2 and minus steel tension layer 3, so those two values there. Subtracting them, you would find that the axial load in our section is 174.3 kilonewtons. The last thing we need to do now is find the moment. So the moment, we're going to be taking about our plastic centroid. I've drawn this big in a second, I'll show you now. But just to remind you, the compression in the concrete acts at the center of the rectangular stress block, which will be gamma dn on 2, and the compression and tension in the steel layers will act at their corresponding layers. So in that layer, and that layer. So